Heidi-ho, students. Um, Enjoy my lovely voice here. Sorry, it's the best I can do. So this was today's warm-up. We're asked to solve. We're asked to look at the structure of the result. We're asked to identify the name, and then to try to use the structure to factor the trinomial, or in one case binomial, but we'll get there. So remember, x plus 3 squared is really the same as x plus 3 times x plus 3, right? We can't distribute the square in. And then once we've got that, we could use FOIL. Ideally, you can do this without FOIL by now, because this is a special product, or sorry, or a special case. So you should be able to see, all right, that's x squared plus twice this, 6x plus 9, which is 3 squared. The structure here is a squared plus 2ab plus b squared. A is that x, which we've got x squared. B is that 3, which we end up with b squared. And in the middle, our middle term is twice ab, so 2 times 3x, which is exactly what we have. This is called the perfect square trinomial. Not officially part of the name. I like to note the difference between added and subtracted. So we can use the structure to work backwards. If this is a squared plus 2ab plus b squared, well, then a must be the square root of x squared, b must be the square root of 16, and 8 should be twice those two a and b added. So let's check. X plus 4. X squared is a squared. That works. 4 squared is 16. That works. And twice 4 times x, so 2ab gives us 8x. Perfect. All right, moving on. We have x minus 5 squared. Again, we should be able to do it without having to work it out. We should see, oh, this is a special case. But if you're not there yet, no problem. We can write it out. And then you've got x squared minus 10x plus 25. It's basically the same situation as here, except this time we're subtracting. So the pattern here is a squared minus 2ab plus b squared. This is, again, a perfect square trinomial. And it's being subtracted. So if we can try to use the structure to break this one down, here we have x squared minus 12x, so that should be minus 2ab, plus 36, so that should be b squared. Well, let's think about it. The square root of x squared is going to give us x, and the square root of 36 is going to give us 6, and we should subtract, and then that binomial should be squared. Let's make sure it works. X squared minus 6 squared is going to give us that 36, and then the 2ab is going to be twice negative 6 times x, so that should be negative 12x. Perfect. Moving on to our last one. This time we're subtracting one and adding the other. It could be flipped. And, well, if you do FOIL on this, you'll end up with x squared plus 7x minus 7x plus 49. What you need to recognize is that these two will end up canceling out, and all that we are left with is x squared minus 49. This is the tricky one because you lose your middle term. The structure of this is simply a squared minus b squared. And it is known as the difference of perfect squares, or a difference of two squares, because remember, this is a square, and we've got the difference of it. And if we try to use that pattern, well, theoretically, we should just have to use the square root of a and the square root of b, and then just add it once and subtract it once. And then we can double check to make sure that works. This is going to be x squared minus 8x plus 8x. We'll cancel that out. Minus 8 squared, which is minus 64. All right. On to today's lesson. So we're basically taking that special cases that we learned before. Those not shortcuts, but quick patterns that you should be able to recognize. And now we're going to use them backwards to factor special products. Let's start with the trickiest one, the difference of two squares pattern. So as I mentioned in the warm-up, we have a squared minus b squared is the same thing as a plus b times a minus b, or you can flip them. So here's an example. We have 4x squared minus 9. Well, 4x squared is the same as 2x squared. And minus 9, 9 is the same as 3 squared. So there's our a and there's our b. So we should be able to say that we add a and b and then we subtract a and b. So here's an example. Y squared minus 16. It's the same thing as y squared minus 4 squared. So y should be our a, 4 should be our b. We should be able to add a and b and subtract a and b. Simple enough, right? And if we think about FOIL, we end up with our answer. You can double check to make sure that you're right. 25m squared minus 36. Well, 25m squared is the same as 5m squared minus 36 is the same as 6 squared. So there's our a, there's our b. Add it, subtract it. Double check your answer. X squared minus 49y squared, that's going to be x squared minus 7y squared, because that's the same. So there, the square root of this is our a, the square root of this is our b. So we add our a and b, and we subtract our a and b. Last one. Now let's see. Oh, well, the square root of 8 squared, that's not going to work. That's not going to work at all. But we forgot to look for our greatest common factor. Well, maybe you didn't, but I did. So what we're actually looking at is 2 times 4 squared, 2 times 4 minus 9n squared. Because all we had to do was half these. And now, so that means that we have 2 times 2 squared minus square root of that is going to be 3n squared. And now we just need to factor what's going on here. This is 2 is our a, 3n is our b. So we have 2 times 2 plus 3n times 2 minus 3n. Easy peasy. Alright, this is the easy ones, perfect square trinomial patterns. We have a squared plus 2ab plus b squared is the same as a plus b squared. So for example, we have x squared plus 6x plus 9. So if this is our a squared, and if this is our b squared, then we can check, is our middle term twice x times 3, or 3x. Is that twice 3x? Of course it is. So now we have our a of x, we have our b of 3, and all we have to do is say a plus b squared. So x plus 3 squared. Same when we're subtracting. A squared minus 2ab plus b squared is the same as a minus b squared. So for example, x squared, that's our a, so we're looking at x squared. 25 should be our b squared, so is that 5 squared? It sure is. And then we just need to think about our middle term. Is this twice 5 times x? And sure enough, negative 10 is twice 5 times x. So we have our a of x, we have our b of 5, and we can just write out our binomial, x minus 5 squared. And we could use FOIL to double check. Of course, you didn't think it was going to be that easy, did you? So, factor this polynomial. Here's a hint for you. I'll go ahead and pause, and I will wait here for you. Did you pause? Do you have an answer? All right. So if I had to factor out negative 3 first, because not only do we want to get rid of that 3, but we also need to get rid of that negative. So when I factored that out, I ended up with y squared minus 12y plus 36. And I looked at my pattern. Do I have an a of y? Do I have a b of 6? And is my middle term 6y? It sure is, negative 12y. So I can just use my special factors and break that down. Alright, go ahead and move on to the next one. I'll pause and wait while you do this. So the hint was to get rid of the fractions first, but even then you might have had trouble. Remember, to get rid of the fractions, to clear the fraction, we're going to multiply each term by 9, and technically we should do it to both sides, even though we know what this is going to give us. Then we end up with 9x squared plus 6x plus 1 equals 0. And you might be looking at this and thinking that I've led you astray because this does not look like one of our patterns, but I assure you that it is. Let's think about the square root of 9x squared. Well, that's going to be 3x squared. And then this is twice 3x. And then this is the square root of 1 is 1, right? So 1 squared. And really I should have written this as 2 times 1 times 3x. So if 3x is our a and 1 is our b, this is twice 1 times 3x, which is what we've got there. So this factors actually to 3x plus 1 squared. And what I forgot to do is say that equals 0. And then that means that, well, there's no alternate universes to go to. We just need to think about our binomial. 3x plus 1 must equal 0. And then that means 3x equals negative 1. So x equals negative 1/3. And we only have one solution of negative 1/3. All right, thank you for bearing with me. I will see you next class.